So just give a couple of minutes, start it. So welcome everyone to today's event, Arduino Day. So today's event is presented by STEM Smart Labs in collaboration with Arduino. So the theme of the event is Discover the Inventor in You. Today Arduino is celebrating 20 years of its journey. So people who have joined, who already have used Arduino or who are not introduced to Arduino will learn more about Arduino today, or what it is, how it can be used and things like that. So the goals of the event is primarily an introduction to Arduino. We will see what Arduino is and what are the applications where Arduino is used. Then we will have a blog-based coding workshop where we will have a few applications that we will try hands-on. And then we will go into the launch of Arduino UNO Take R4 board, which is made in India. So we will see the details about that as well. So that's a high-level agenda for today. So the first thing is introduction into Arduino. So Arduino is actually an open source electronics platform primarily, and Arduino was designed to simplify complex things. So whenever we discuss or whenever we think about an electronics application, there are two components which are primarily the hardware part and the software part. The hardware part is complex with wiring and components and things, and the software part is also complex in a sense. So Arduino took an approach where they can bring a lot of complex things into a simple board with the inbuilt capabilities. And also from the software part, Arduino introduced a lot of open source libraries which can be integrated into your application very easily. So if you look at the slide on the right hand side, this is the world that we live in. It's a smart world, right? Everything is smart, including the cities, the homes, the schools that we study. Everything is smart. Inside the home, we have smart lighting, smart water management, smart appliances. Everything is smart. So everything is becoming smart with help of automation, which involves both hardware as well as software. So Arduino as a platform helps or empowers makers, hobbyists, and educators to build these wonderful applications, which helps people to do fast prototyping, to learn about electronics, and solve a real life problem with this prototype. So here on the slide on the right hand side, you see a smart plant watering system. So this is built using Arduino, where it kind of measures the soil moisture level, and when the soil is dry, it automatically pumps water into the plant. So this was designed by one of the students using Arduino. So these are all small applications that are made smart with the help of these kind of platforms. So we will see what are the other things that we can perform and how to reduce this complexity. So primarily whenever we discuss about these electronics applications, people think it's complex because there is a lot of wiring, there are a lot of components, and a lot of difficult coding. So how do we teach or simplify these things to our students so that they can start early in their life with tinkering and making all these applications? So Arduino has taken one step of introducing this platform. We will see what are other things that are available with us to make things more simpler. So I mentioned about the software part where Arduino provided libraries and things. But for students at an early age to start engaging with a platform like Arduino, the industry moved towards something called block-based coding. So today we will see what this block-based coding is. Okay, we will go through a few applications in this, and then we will take it from there. So today we are going to introduce you to something called an inventor space. Okay, so let me just share it. So this is inventor space. Okay, our team will put the URL in the chat box so you can open. So you can sign into inventor space with your Google ID. So once you sign in, you will be in this page. So I'll briefly describe about what inventor space is, how the journey of an inventor is. Then we'll go into the Arduino. So primarily, so how we envision an inventor's journey is in 5 stages. The first stage is stage of inspire. So this is the stage when there is a problem that you are very much interested, that you want to solve, and you are inspired by that problem. The next stage is like you start imagining like how to solve this problem that you're facing. What are the ideas that I have? So then you list your own ideas, like, okay, these are the ways that you can solve this problem. The next step is building around that idea. So that is when platforms like Arduino help you to do faster prototyping. So you build it, then you play with the invention that you have created. You then again try to iterate it multiple times to make it better. So once you find your invention or the idea has come to a reasonable state, then you share it with your friends, your school, your community. Okay, so that is how the journey of an inventor is, and this is what that we have defined as part of inventor space. So here today, being Arduino Day, we'll go into the Arduino journey. So clicking on Arduino journey, we'll launch inventor space for Arduino. So if any of you, I'll give you a few minutes. Like if any of you have trouble launching inventor space or this Arduino page, do comment in the chat box. Our team will help you out. So I want everyone to come to this page. Okay, I'll give a couple of minutes for you to come to this page. If you have any trouble, do message in the chat box. Our team will help you out. All right, hope everyone is able to log in. So first thing that we want to go or do today in today's application is a simple LED blink which is on the board. Okay, the tutorial is called Get Set Go. So here the objectives of the tutorial, learning objective of the tutorial is to learn about loops, pause, and digital write. So when I'm doing this tutorial, you just follow the tutorial, whatever I'm doing, observe whatever I'm doing. Okay, don't do it parallelly. At the end of the tutorial, I'll give you a few minutes where you can try it on your own. Okay, so initially I will do it, you just follow it, I'll give you a few minutes, then you can try it on your own. Okay, so it's get set go. So the idea is to learn about loops, pause, and digital write, and blink the onboard LED. So I'm starting the tutorial. So here I'm going to select a board called Arduino MKR board. Okay, and now the tutorial is started. So the goal of the tutorial is to turn on and turn off the onboard LED to create a blinking effect. Okay. So the first step is to add a digital write block into the for-hour block to turn the LED pin high. So I will teach few color codes. For-hour is green, so loops are green, so everything which is green will be under loops. Digital write is light red, so it will be under light red, so pins. So here is the, if you want to look at the hint, you can click on this, you will see the hint there. So here you can see digital write pin LED to high. Okay. So I'm going to the pin screw category. I'm going to drag. So this is something that has to run on a loop, right? So it will go into for-hour. If there is a routine which has to happen only once at the starting of the program, you will put it in on-stop. So this hint says it has to be under for-hour, so you move it to for-hour. And it says turn the LED to high, right? So here is the onboard LED. You can see that it is not glowing now. Now let me turn it high. So once I turn it high on the simulator, you can see it is turning high. Okay, let me just make it off. Here you can see it's off on the simulator. When I'm turning it high, you can see on the simulator it is going high. So this is a simulator of the Arduino MKR board. Okay, that's what you see. So the next step is to take a peek at the simulator and make sure LED is turned on, that we did. After that, we will add a pause block. Then add digital write LED low, then again pause. So it will be high, pause, low, and high. So this will create a blinking effect. So pause is, so in the hint, pause is green. So you go to the green one, loops. So you'll find pause here. And the hint says I have to pause for 500 milliseconds. So I'll pause for 500 milliseconds. Then I have to make it low. So I'm going to pins. And I'm going to make LED low. Then again I'm going to add a pause for 500 milliseconds. So here on the simulator, you can see it's rendering now. You can see the onboard LED is blinking at an interval of 500 milliseconds. So this is the first tutorial or the application that we wanted to start. A simple one which you can try yourself. So since today we don't have any hardware kits with you, you'll try everything in simulator. Ideally, the next step would be to download the code onto the hardware, and whatever is happening on the simulator will happen on the board as well. Okay. So I want to give a couple of minutes for you to try it out. And if you have any issues trying out this tutorial, let us know in the chat, and our team will help you out. So I'll give a couple of minutes for for all of you to try it out. If you're stuck anywhere, do message in the chat box so that we will be able to help you out. So So we have a couple of other exciting applications as well that we will do today as part of the hands-on, where you will learn more about block-based coding and Arduino. Okay. And it will be exciting for you guys. Yeah. All right. Hopefully you guys were able to do it. Now we'll move on to the next application. So next application is called Let There Be Light. So what we tried earlier was to blink an onboard LED. Now we will try to blink an external LED. Okay. So the learning objective is to learn how to connect an external LED. So at the starting of the meeting, I told about one of the complexities, wiring and components. We will see how it is getting solved here, how wiring is made simple, and how it is helping students. So let's start the tutorial. Let's select Arduino MKR board, which is a Wi-Fi based board. And this experiment will do turn on and turn off of an external LED to create a blinking effect. Right? So right now, so this is the first step that you have to do. Under the forward block, we have to do digital write to pin D0. So external LED will be connected to the pin D0 and we make it low as a first step. So we go here, I just put it here and D0 and I make it low. So here you can see the LED is getting rendered in simulator and it has a resistor, 330 ohm resistor, and the wires are connected to the Arduino board. We will go into the wiring later there. So this is the first step. So you can see the LED is off now that we checked there. So next is add pause and make the pin D0 high and then add a pause so that it creates a blinking effect similar to what we did with the on board. So pause is the next step. Pause is green. So as I mentioned, under loops, which is green, we'll go to pause. We'll put 500 milliseconds. Next step is digital write D0. So it will be under pins, digital write D0 and make it high. And add another pause for 500 milliseconds. And now you can say D0 goes low, 500 milliseconds, high, 500 milliseconds. And it is in a forward loop, so it creates a blinking effect. It continuously runs in a loop. So here on simulator also you can see the external LED is blinking now with a periodicity of 500 milliseconds. So you can also change this timing. If you want it to be a little bit slower, you can make the period, like the delay or the pause to be 1 second so that it blinks at interval of 1 second. And here you can see an external LED is blinking with just 4 blocks. You made it possible. Next, we were discussing about wiring, right? So here there is something called a spanner kind of icon. So if you click on this icon, it will give you all the wiring information for this exercise. So this exercise is called Let There Be Light. and this can be saved into a PDF, and you can look into the PDF. So I have opened the PDF here. So this exercise is for let there be light. So here you can see the wiring. There is an Arduino board, there is a breadboard, LED, resistor, and 2 wires. So it lists what are the components that you have to take to complete this application. So one Arduino MKR board, one breadboard, and one LED with 330 ohm resistor and 2 wires. The breadboard also you can see it will have the naming, like alphabetical naming ABCD here and numerical naming from 1 to 30 here. So we will use this for our connection. So the next step is to take one cable D0 to J14. So here the cable is connected D0 to J, row is J14 we will connect, and the LED positive is connected here, negative is connected here, 330 ohm is connected here, and the next wire ground is connected from here J18 to GND. So one of the complex things about breadboarding is kind of solved with the step-by-step instructions that we provide as part of inventor space, right? So once you make sure the breadboarding and everything is correct, right? The next step that you actually do is you download the code. So when you download the code, the thing is it will ask you to pair the board if you have the board. So if you pair it, then it will actually burn the code into the board, and you will be able to see that into the board. So it actually downloads a file, a binary file called in the UF2 format, and you will be able to use that file to burn this into the Arduino board. Okay. So this was about let there be light. I will give a couple of minutes for all of you to try it out. And if you have any issues trying it out, do reach out to us in the chat box. Our team will assist you. Hope you're able to do it. If you have any issues, do let us know in the chat window. Our team will assist you. So you should be able to make the LED blink in the simulator like you're seeing on the screen. Okay. All right. So we'll move on to the next one, the next tutorial that we have. So the next one is the interesting one, the favorite one for students as well. It's called fireworks. So here we'll be using a NeoPixel strip. So like before, we will select Arduino MKR board for this tutorial, for this application. So it creates a fireworks effect in this strip. So the first step is to on start. So on start, set the strip with the details of what is the strip, which port it is connected to, and how many pixels. So on start is here already. If you go to live, more, there is set strip. So this will come into on start, and the port is A0. So if you see here, the port is A0, right? And the port is A0, and the number of pixels is 8. So this is setting up. This is an initialization code. So that is done on non-start. So it happens only once. Okay. So any code which runs only once will happen inside on-start. So this is an initialization code. So it happens in on-start. And we are designing the application for a NeoPixel strip which has 8 pixels. Okay. And it is connected to A0. So the next one is to show the animation. So the animation should be continuous. So it will be in forever. So with strip, you show the animation, the fireworks or the rainbow color of with the periodicity of 500 milliseconds. So I go to light, more strip, show animation, and I'm giving show the animation for 500 milliseconds. So here you can see the animation is going in the simulator. Okay, so if you want the animation to go a little bit slower, you can change it to 1 second, and you will see the animation is going. So such a complex application to run an animation is very simplified now. So as I mentioned, you click on this spanner icon, you will find the connection of how the wiring is done for this firework. You can save it as PDF and you can open it. So here I have the fireworks PDF open. So it says what are the components that are required. So an Arduino board, one breadboard, one NeoPixel strip, and some 3 wires. And here you can see the breadboard has all the markings with the alphabets A to J and numerically 1 to 30. And here you can see the NeoPixel strip has to be taken, and the cable, the jumper has to be connected between I17 to ground in the board. And the next step is to connect the cable from A0 to I15. So this way you complete the circuit, and once you click on download, you will be able to program the Arduino board with a fireworks animation, which you can see. So this is actually very interesting application when you do it on the hardware, because it's really colorful. So I'll give you a couple of minutes to try it out. You can also try to change the animation and see how it works. There are different color rainbows or fireworks available. So you can try changing these animations and see how it goes. I'll give a couple of minutes for every one of you to try it out. So if you have any issues trying it out, do reach out to us in the chat window or email support. Hope you are able to try it out. We'll go to the next one. So this application is called Make Some Noise. So here we will learn about tone, how to use the buzzer and analog right. So we will select the Arduino MKR 1000 board. So we'll learn how to play a tone. Okay. So this code is very simple. It's like play a sound until done. Okay. So now I'm going to do one thing. So I'll put it in on start. Okay. So that you will hear this sound only once, right? So like I mentioned, right? Like on start is a loop, is an event that triggers only during the start, during initialization. It will happen only once. When you move into forever, it will kind of play in a loop. So I moved play sound into forever, being played in a loop, right? So this kind of uses an buzzer and it has wiring. So like I mentioned earlier, it will have assembly instructions and you can save it. There are multiple tones that are available here. You can try it out and see for yourself, like how these things play out. So I'll give a couple of minutes for you to try it. If any of you require assistance, do reach out to us in the chat window or team will support. So I see there is one question about the volume. So I think so. If you click on finish, if your tutorial is done, you can. If you go to music, there are a lot of blocks which are specific to music. Okay. So here there is one block for volume also. You can try it out. So there will be, so in the tutorial mode, it will show only a subset of blocks which are used in the tutorial. But once you complete it, you go into the project mode, you will see a lot of blocks which are under music. So you can try it out. The APIs, the blocks that are available. Okay. So hopefully everyone is done with the tutorial. Let's move on to the next segment. So it's about the launch of the Arduino UNO Outdoor Egg board, so which is a made in India board. So earlier, the previous generation board was called Arduino UNO R3. So that was an 8-bit microcontroller based board. So this is the next generation board. This is based on a 32-bit microcontroller. It has two variants. One is the Minima board and another one is the Wi-Fi board. Since this is a 32-bit based microcontroller, it also has better memory capacity and inbuilt peripherals in this board. In the Wi-Fi Arduino UNO R4 Wi-Fi board, you have a 12 by 8 LED matrix, which you can use to play animations and things like you can put some sensor data and all. So similar to whatever we did with the fireworks, you can kind of use the onboard display in the UNO R4 board to play with it as well. And it has an ESP32 chip on board on Arduino UNO R4, which helps you to provide Wi-Fi and Bluetooth capabilities. So if your application has Wi-Fi and Bluetooth capabilities, and this board will best suit these applications. And right now this is under production, and it will be available by end of March. And this board is made in India board, so we should be really proud of this initiative that is done by Arduino, and we are looking forward to use this Arduino UNO R4 board in our applications. So Ruby, you want to say something? Ruby, you're on mute.
Yeah. So is it the end of the?
Yeah, I have one more thing, but you can talk. So Ruby is actually from Arduino. She has joined this session for Arduino Day. She will say a few words. Yeah.
I would just like to make this session a bit interactive in case of the launch. So I believe that everyone are the students here. So just you have the option to raise hand, right? So how many of you are using the UNO in your projects? Arduino UNO, just raise your hand with the option which is there. Only one? Have you never, others? Have you ever used Arduino UNO? Okay, so just to be more clear, so till now what Arduino UNO you have been using was R3, right? But now just now the second question. So again, please raise your hand. How many of you know that whether you are using the original or the copy board? Just raise your hand. How many of you know that you are using the original or copy board? Copy in the sense clone or counterfeit. Not sure. Okay. So just for your awareness, because you all are the end users of Arduino, so you should have this information or awareness. So do you know that more than like 90% of us are the board that we are using are not the original boards. So what we use, we get it in 200, 500, 400 rupees. Those are the clones or the counterfeit. It means that they have copied the Arduino design and they have given the name Arduino. So if anyone is copying the design of Arduino microcontroller board and they are manufacturing it, it's okay because Arduino is open source, you all know. But if anyone is using the name Arduino and they are selling it by the name Arduino, just by printing this Arduino logo and all, these are called clone and counterfeit. So you should be aware that how to differentiate between clone and counterfeit. So just give me 1 minute, I'll bring the original packet and I'll show you how to differentiate. So this is the original one. So when you buy the original one, it comes with a package like this. And with a serial number like this. And when you open it, the biggest differentiation is that the original you get with a safety manual, this, with a user manual, and one sticker. So sticker I don't have, maybe I removed that. But when you get one sticker. And in the original one, you get this shield. So this is how original looks like. Till now, we have been using R3, but the copy version comes in blue color. But R3 never comes in blue color, it comes in green color. Now we have launched R4, which is the revision of R3 with more possibilities. And what are the more possibilities? Like in this one, there are two, minima and Wi-Fi. This is the Wi-Fi one. Now it comes with C-type connectivity, which is more easier because we all have USB C-type, right? For our using for our phone and all, so we don't need to buy an extra USB. Then it is 32-bit as sir mentioned. Then it is powered by Renesas chip. If you know about this, this is more powerful and faster. This is having CAN bus and HID feature. When you use the high-end things like you want to make it like a keyboard and mouse, it can work as a human interface device. And CAN bus means it can communicate as well. You can use for the communication project as well. It is coming with Wi-Fi and Bluetooth facilities, means when we were shifting to ESP32 for our IoT projects, but now you can do with UNO as well, all the IoT and AIML projects. Means it's like simpler, but with more advanced features. So this is the news that I wanted to share with you all. So are you excited? Now the most important thing for India, this is exclusively Arduino Ek R4, Hindi wala Ek. So till now you all know that UNO word is very famous, right? So we don't even say Arduino board, we say UNO board. So UNO word is very famous, but UNO means one in Spanish and Italian, right? Now this UNO got changed to Hindi wala Ek, exclusively for India. So it's a very proud moment for us that now this very famous word will be known as Ek, and we will call it as Arduino Ek R4. Okay, so by this month end, you'll get the this R4 Ek board in market. I hope you all are excited to shift to this. Last important part, if you know that original used to cost very expensive, right? Why we started using the clone and counterfeit? Because original used to cost us around 3,000, 4,000, right? Whereas the clone one costs around 200, 300, 400 like this. So the most exciting news is that because now this is made in India, manufactured in India, and sold in India. So that's why now this will be less expensive. So it's like the minima you get between 800 and 900 something, and Wi-Fi you get around 1300 and 1400 in between. And if you go to the clone of R4, then that clones also comes in 11-1200, or maybe there are very rare clones or counterfeit of R4 available. So it's exciting news that we can now shift from the clone or counterfeit to this original one. If we have time, do you know that what are the advantages of using the original one? Have you ever experienced that while using the board, sometimes it gets burst and you lose the connectivity with the software? It's very difficult to connect with software. Issues happens. Have you experienced all this when you work with the boards? Anybody can just write in chat as well that have you experienced the connectivity with the software? Yes. And it burst, right? Lost 3-4 boards. So this is because we use clone and counterfeit. We don't use the original. So the exciting thing is that when you use original, there are very 0.01% faulty boards reported. Means you get the replacement, even you get warranty for 2 years with these original boards. And there are very less, means not a single board you'll get which get burst. And there are regular firmware updates with the original, which never happens with the clones and counterfeit. So because there are regular firmware updates, so that's why the connectivity issues will never be there in case of original one. And then you get the safety manual, so it won't burst. You all are safe while using it. It comes with the shield, so when you keep it in any of the electronic item or metal item, so it is safer to use. So these are the advantages that you get. And yeah, one more thing, that when you use the Wi-Fi one, you get the access to the Arduino cloud space for free for 30 days. So that's also one advantage of using this. Cost, as I mentioned, so cost will come for this Wi-Fi one, it will be around between 13 and 1400 currently, launch price, and minimum will be between 800 and 900 launch price. Yes, that's it from my side. Hope you shift to the original one now. One last thing I would like to show is, have you ever seen Arduino Project Hub?
You can share it.
Yeah, I'm just opening it and then I'll share. Yes. Okay. So this is Arduino Project Hub. So if you're not aware of this, so let me tell you. So all the students like you and different makers, they do project using Arduino boards and Arduino products, and they publish their project here in Arduino Project Hub. So what you need to do is you can go to this new project and you add your own project, but there will be evaluation round. Your project will get evaluated by the Arduino team, and once it gets approved, that will be published in this Project Hub, and you'll get the global recognition. So what exciting part is that till now there are no project using R4 because this is exclusively for India and it is yet to come in the market. It is coming this month only. So when I type UNO, there are, or UNO R4 maybe, so there are projects with these boards, but there are no project with R4 currently. So you have the chance to be the first one to add projects with R4 So get your first boards from the market and create exciting projects. Upload that in Project Hub once it gets approved, and this is high chance to get approved because the R4 is not there currently. and then your project will be published and get global recognition. Yeah, that's much.
Thanks, Ruby. Thanks for explaining the differences between the Arduino clone and the original board, and showing us the project dashboard also, so that we'll be able to use it whenever we create applications using Arduino R4A. So the boards will be available end of this month. You can go to the links provided here and all get your Arduino board. So next thing is, so we discussed about two things from the beginning, right? Software complexity and hardware complexity, and how we are trying to solve the things. So in the hardware complexity also, one of the important thing is breadboarding and wiring. So we are actually planning to launch one kit which is primarily using Arduino UNO R4A, and it will have components which are already part of the kit, and you need not do any wiring or breadboarding. So primarily all these components are linked to the board. So once you have the Arduino UNO R4 board, just connect the board to the kit, and you will be able to interface all these components with Arduino egg board. Okay. So here we have components like servo, NeoPixel, fan, an ultrasonic sensor, an OLED, IR, LED, temperature, humidity, buzzer, switches, and all. So you can use all these components and create interesting applications using Arduino UNO R4 egg board. We also have 4 external connectors that you see here, which you can connect to external sensors. So if the sensors that are, if your application requires extra sensors, which has to be interfacing with UNO R4, you can use the groove cable and connect to the external sensors and continue with your application. So this is a fast way of doing or rapid prototyping. It will help you to do rapid prototyping for the application, and you will be able to tinker it multiple times, iterate it, and get into a reasonable finished product. So that's about the experiment kit for Arduino UNO R4A, and we are planning to launch in the month of April. So as a student, as an educator within EdTech or a teacher, you might always have a lot of questions like, if I have to implement this, if I have to do it, how am I going to do? How am I going to integrate Arduino? Or how am I going to integrate STEM-related solutions? So you can always reach out to us or write to us. Okay, we are there to support you, and we will make sure your journey becomes smooth with Arduino as well. So thanks everyone for attending the session. Hopefully you learned a lot of new things about Arduino in this session, and looking forward to your applications that you're building using Arduino UNO R4A. Thanks everyone. Thanks once again for attending. Have a nice evening. Bye-bye.